feel like an inductor drug dealer. There's a reason that I own all these chokes. It's because of this part here. So the customer states, we're looking at this part here, it should not look like this. This one's melted down. The customer states that he was talking on it as he normally did, and then the smoke came out. Okay, so no helpful information there. This is a 667 with Toshiba's. It's a 2290 drive in 4 2879s. Let's back out just a little bit. This is one of my boxes that's been here before, right? So then we have to ask ourselves, why did this choke smoke? This choke is here to help throw the 12 volt portion of the amplifier completely out of resonance. For a period of time, the output RF and the positive 12 volt share the same trace. That's very common in a lot of different industries, and especially in most of amateur equipment. It's okay to use the relay for more than just RF. It is. But when you have a failure in the relay, it's usually a lot more violent when you've got 12 volt going through it and RF. But I digress. This is the way Texas Star has done it for decades and decades and decades. Listen, all the shit that I talk or have talked about Texas Star, at the end of the day, we have to accept the fact that this company has been in business forever. Okay, before it was Texas Star, it was Outcom, and then before that it was something else, and then before that I'm sure it was somebody's garage band, okay? At the end of the day, this design has, for the most part, not been that radically changed for a long, long time. So it pains me to say this, but I say this to most amp repair guys and new builders. You should probably figure this amplifier out and make it as friendly to you as the back of your hand or your wiener, because you're going to work on way more of these amps than you are anything else in the market. There are probably more Texas Stars in the market share as a single name device than anything else. And what I mean by single name device, there is one company that has produced underneath so many different names the exact same form function of amplifier that no one will ever hold a candle to them. But it's underneath multiple different names, and it's had many different owners over the decades, and that's Palomar. I would argue that there is more Palomar-ish, either it be solid state or their sweep tube functions, amplifiers, than there could be of anything else in the market share. Second only to Texas Star. The difference is Texas Star has held on to one name and one product design line for longer than Palomar. I mean, think about it. You've got the 600 Elite, the 600, the Palomar 600, the PAL 600, the PA 600. That's all one product with a different nameplate on it, where Texas Star has just stayed Texas Star. Okay. So the truck stop throwaway amplifier versus the one that everybody wants to get repaired all the time. That's the difference. Let's start with the bottom side of the board. This is a 667 board, okay? And we're gonna start with this trace right here. And you're like, well, my God, BBI, that trace is all the way over here. You're right, it is. Just to give you guys an orientation in how this is set up. Remember, we're gonna flip the board over. Okay. This one trace here and here and here is our 12 volt switch. So that comes to here. Right here. Right here. There is a shared trace lead that's on the top side that marries up here, right here. Where's that choke hookup? It's right here. So when you press the on button, 12 volt source now makes this hot. Hence the reason why the relay sometimes keys when you turn on the on-off switch. It's this transistor charging up and going into operation. So the relay will stay open, then it closes, and it opens again. So this choke stays static, and it goes from here to here. Okay? This trace backs up, and it goes to this capacitor. But then, from here to here, so when the relay closes, there's 12 volt hot on this lead. When this relay closes, it goes to here. Well, that in turn goes to this trace. This trace is your output RF. All of your output RF goes down this trace. Okay, so you can tell somebody tried to mess with the output tune on this amp. They added a capacitor here. It goes to this trace, and then it goes along the back side of the amplifier on this trace here through these solder vias right here. From there, in turn, it goes to the bottom side of the amp, and it goes to here, to this trace. And it follows this trace along, and it comes over here to the right front corner of the amp, which is now over here. It pops up actually right here on the amp. There's some magical things that take place at this point on the amplifier. It comes up on this trace right here. Right here. Right there. Okay. We have another choke. And that's to try and get the RF off from it being passed through over here. Because remember, there's hot RF on this lead to here. Well, this is the circuit that drives our metering circuit. This resistor, this diode, and then this resistor over here. This voltage that we're going to capitalize on from this choke to here is what drives our light. Well, that in turn drives this resistor. Please note this red wire that's right here. And it runs over and it goes to the backboard, which I commonly refer to and about everybody else in the industry calls the pallet, the rear pallet. And then we'll see the circuit repeat itself. Here's this resistor. Then once again we have an inductor with choke on it, ferrite. That's to keep the RF on this transformer. Over here we have a 1.6 ohm resistor underneath this positive lead. And that is what controls the amount of voltage and current that gets driven onto this transformer. We have the same thing going on here. We have this resistor, then we have a choke, we have a resistor here, which is a 1.8 ohm resistor, which is down here by the driver's section, right here. And then have a choke, another common trace, and then another choke to the input transformer. The fact that this resistor isn't burned up is a good sign. Or pardon me, this choke isn't burned up is a good sign. All the current that feeds this resistor, and this light all go through this choke. Period. So if this resistor isn't burned up, that tells us that the fault is somewhere between here and here. So now we've narrowed down half the amp. Just replacing this choke as soon as you key the amplifier, which is going to switch the 12 volt onto this portion of the circuit, okay, that choke will just burn up again. So I'd like to say, from a preliminary examination of this, like, so when I open up the cabinet and I look at this, I first look at this choke, then I look over here. Now what's really common is somebody to go in and work on the amplifier and a little piece of solder fall down someplace in this area, because there's a lot of very tight traces and components that are very close together, and this choke will start to burn up. This choke only burns up when there's a short from here to back here. Only time. I have seen it though, where there is a short Like I've had this light bulb short out and cause this choke and that choke to fry. I have seen guys short this circuit out with bad soldering skills, and then this choke and that choke fries. But if this one's burning up on its own, that means there's something else from here back to here that's burned up. So let's reverse the traces again. That means something from here to here is shorted out to ground, or something from here or something from here on these three traces is shorted out to ground. Well, what components do we have in that circuit? Well, we've got this capacitor right here. We certainly do. We have this capacitor right here that could be shorted out. We certainly do. Although I would strongly argue that I don't think it's this cap and that's cap. And I argue that from the standpoint of I have not seen them fail. I have a feeling, a sneaking suspicion, feeling that all of our transistors are okay. Usually this resistor will go up in smoke if there's a short anywhere from here and here. That's these three transistors, and there's a reason that this is 1.8 and there's a reason that this is 1.6. And it has to do with the amount of load that's applied upon it. There's significantly more current draw because of this extra transistor on this circuit, which works exactly the same as this circuit. There's more current here than there is present here, or draw here. I have seen this get so many problems from here to here, and 99% of the time it's some shit that's underneath the board, or something got hot enough to where solder started to move and shit shorted out. And I've seen every which way you can to fix it. People stick cardboard, people stick Post-it notes, people stick duct tape, people stick Scotch tape. I've even seen a layer of super glue laid down and a layer of silicone laid down underneath the board to keep the thing from shorting out, other than just fixing the problem. It's the quick, easy fix, right? Oh, we'll just stick a piece of paper in there. I've been known to do it too. Slide a piece of paper underneath there, the amp works. The problem is, in my mind, now I gotta take the whole board out and let's go see what's going on underneath and fix where the paper's making contact, or keeping the board from making contact. There is a very rare, very slim, but there is a possible chance that we end up having a problem on this trace here. I know this box is very confusing. Texas stars can be very confusing until you let your brain relax and you just learn the trace and go, oh, okay, you learn the circuit. So what I'm gonna do in this situation is this board's gotta come out. I have to visually inspect the trace on the backside. And for me to properly do the repair anyhow, for me to check this cap, the only part that I can check is this from the top side. But for me to properly check this part, I have to pull it out of the board, right? And this is a through-mounted component. So this whole thing has got to come out. But I have a feeling that the transistors are okay. Now, to achieve that, we have to disconnect this, we have to disconnect this lead, we have to disconnect this lead, we have to disconnect this lead, this lead, this lead, and this lead. We have to disconnect this, disconnect this. We could disconnect over here on this. We have to unscrew both of the, we have to get our Allen wrench down in here, unscrew this, unscrew that. And we have to disconnect this, disconnect this wire here, and then pop these 4 screws out with the additional 3 screws that are holding, or 4 screws usually. It's this one, this one, this one, and this one. Pull those 4 screws out. And then we can slide the board out and we can take a look at what's going on underneath, if there is even a problem. I'd rather jump to the extreme thing than try to chase my tail down the tunnel of the not so extreme thing, and it also gives me the opportunity to measure things from both sides. But this son of a bitch burning up, 99% of the time it's because something over here shorted out. Right here. Or it's the trace going from and to here, shorting out. Because there's very little back this direction that can cause that problem, and there's very little this way on this trace that can cause that problem of that burning up. Still, it's easier to work on if I just pull the whole board out. Okay, let's do just that. Okay. So the first thing that we do is we lift this choke. Okay. And we see if we still have the short present from here to here, which we don't. Which tells us now that it is farther up the chain. And I'm surprised this choke isn't burned up. So then the next thing we do is we pull the load resistor out. Because remember, right on the other side of the load resistor, we've got our 1.5 ohm resistor or 1.8 ohm resistor. We get rid of that. So now we've eliminated that portion of the circuit. So then the next thing we do is we got to go eliminate our frickin' light bulb. So if I have this on resistance check, the light bulb represents 15 ohms worth of resistance. That's across the light bulb elements itself, 15 ohms. So now we eliminate that. We know that this is an electron generator. It's a shorted connection that boils off electrons and emits them in light. This resistor here is 25 ohms. And then the resistor going to ground, we can look at it this way. We'll see that we're at 27.5. Okay. And that's because this resistor here is 1.6 ohms. It's 1.8. This one's just been hot. It's okay, it doesn't affect anything. Or pardon me, this is a 1.6 and the one in the back's 1.8. Okay, so that tells us that now our short, our excessive current load is somewhere in this circuit. So it's either going to be this resistor here, or it possibly could be this resistor here. These are part of the loading circuit that drives the meter. This solder pad, this one here, goes down and it pops up right over here. That's this trace here to here. So we're going from here to here. And this is the one that's got our sandstone and our choke attached to it. So when we lift this choke and we lift this resistor and we take the light bulb out of the equation, we should not have any kind of conductivity from this trace to ground, or pardon me, from this trace to ground at all. Oh, you dirty little booger. So we got 15 ohms, right? This disc capacitor, this little blue capacitor here, which is C42 on the schematic diagram. We'll come check this cap. Nothing. Nothing. All right. Nothing. Nothing at all. This cap on this board has gone open. According to the book, C42 is 0.064 UF, or it says 0.068 UF to 1 UF worth of capacitance. This is here to help throw the RF off this side of the circuit one more time. Because remember, we're grabbing our signal source over here, grabbing our signal source over here. So we have to give it a signal reference. So then we're going to have our choke and our capacitor. So this is going to kill and make it so it doesn't have any inducted signal. And then the capacitors to help throw this off of out of resonance completely. So then we can use the 12 volts to do our bias. That makes sense? So if this cap goes open, now it represents a short to this choke, which then translates to a dead short on this choke over here. Well, it's always going to fail at the weakest link. So if our short's over here on the front side of the board, where the most current's going to be present over here at the beginning of the circuit, you can see that this one's slightly, very slightly, very slightly discolored directly in the middle. You can see the discolorization once I point it out. It's right there. A little darkened band. Most current's going to be over here, closest to the switch source. This cap breaking down is what caused the problem, I personally feel. So we'll pull this out. We'll clean all these traces up because we don't have anything hanging down here. So I'll go in here with some solder wick. I'll clean this up. We'll pull this cap out. I'll replace it with something new, and we'll put the whole thing back together. was an interesting series of developments there, working on this thing. So, in the process of cleaning it and getting ready to put it back together, I noticed that this 1000 picofarad capacitor was gone. So I don't have a smaller disc, so I just went ahead and used this upgraded cap. Also, this 22 nanofarad capacitor, this yellow one, was completely smoked from the fire of the coil. Completely fried. That's this one here, was fried. The key in transistor was working until I turned the voltage up to 15, then it would stay engaged. This is the one that we pulled out from over here. This cap, though, was the wild card. Down in here, down over here by the preamp, you see the yellow capacitor here. Also another 22 nanofarad capacitor. It was getting hotter than a firecracker as soon as you key up. And this choke was still getting a little bit warm. So I changed out this cap to a new one. You could tell it got damaged when somebody decided they were going to replace the preamp transistor. And you could see where they laid their soldering iron against it. So between this cap opening up, this cap going bad, this one disintegrated, I think, from the heat of the fire off of this choke when it burned up. This one here was damaged from the heat of the fire of the choke burning up, and I'm pretty sure that the key in transistor was also damaged when this thing decided to burn. So, all that aside, let's go over here and let's start running it through its paces. So we'll turn the amplifier off. We're up on 15 volts. Hello, 1, 2, 1, 2, 1, 2, 1, 2, about 28 watts peak. Hello, 1, 2, 1, 2. Up and running. Let's check our preamp. Preamp is working. Let's check our dial-a-watt. Hello. Dial-a-watt's working just fine. Sideband delay. Hello. Working just fine. Okay. Release our delay. Now let's go up here and we'll look at our input reflect. It's our 2950 with a 5 watt slug in between the 2950 and the 667. And 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1, 1, 1. Hello, hello. Shut the amp off. Hello, 1, 2, 1, 2. It's arguably one of the better pass-through tunes and input tunes I've seen in a long time. But then again, it's still got the input attenuator in it. Whoa, where are you going, camera? If we pull this resistor out, we get a little bit more over here, but then we have a really high input reflect, and I don't want to mess with that. So, amplifier fixed, does what it's supposed to do. I think it's ready to be boxed up and sent off back home. So gentlemen, I know that this looks like through the magic of cinematography that this only took about 20 or 30 minutes to fix. This actually represents about 5.5 hours worth of work straight. About an hour and a half of that is prepping and set up for video shots. So it's like a 4-hour process to pull this board, disconnect everything, solder everything appropriately, wash everything, put everything back together. Pro tip to you guys out there that are trying to do this for a living, if you go back and you look at the time-lapse photography, you'll see the spacers that are underneath the board. I got tired of trying to chase those. Don't use super glue. Don't use anything, and you can use a little bit of thermal compound to hold the washers in place. But I learned from a good friend of mine, his name is Zane, over at Big Rig Radio. He's like, oh man, I just soldered them some bitches in place. And that's when the light bulb came on. I'm like, oh yeah, okay, that makes sense. You just take a little bit of liquid flux, you put it on the washer, put the washer on the trace, heat the washer up, add a little bit of solder, the washer solders to the board. It makes for a better electrical connection anyhow. And when you go to tuck the board back in, everything stays where it should. I also want to yell at my buddy, Mr. 713 out of South Maryland. It's Chris Roy Sr., by the way. I've been struggling trying to find tires for my dually. When I bought my dually, the guy that owned my dually put tires on it that were more designed for show than they were for use. They were a 4-ply, 285, 45, 22. Mr. 713 over there is a tire guy. It's one of many things he does. And he was able to explain to me and help teach me how to look for the right kind of tire, and then it was up for me to go hunt down and find a company that would manufacture them. I did find one tire that will work for that size. It ended up being a 305 40 22 or a 31 by 12.5 by 22, but it's a 12 ply tire. So I went from a 4 to a 12 ply, not an E but an F load, so I can run up to 90 psi if I wanted to, but that'll make the truck ride really rough. So yeah, you guys get it. I just spent a last couple weeks learning a lot about tires, ply count, build construction, sidewall construction, yeah, widths and so forth, and he was able to walk me through that and help me out, and I just wanted to give him a big shout out. Thank you, Mr. Roy Sr. Appreciate you, bud. On that note, I'm going to wrap this up, call the customer and let him know his shit's done, get ready to box this thing up and send it home. Questions, comments, or if you're having a problem with your amp, don't hesitate to give me a call. I'll do whatever I can to help you out. As always, big shout out to our friends at Penna Labs. Remember, mention my name at checkout or call them on the phone. You're going to ask for Scott, extension 119, and he'll give you a 5% discount on sale. Super shout out to Siglant Bird, Coaxial Dynamics XS. Thank you, our friends on Patreon. I'm starting to notice a phenomenon here on YouTube. Even if you have the thing set up not to play ads, YouTube is now getting so hungry and so desperate for money, they're forcing channels that have not been monetized or are monetized like mine, and they choose not to play ads in the middle of their shit. YouTube's just saying you're going to have to do it anyhow. So I don't know how much longer this is going to last without ads. We'll see. I'm going to keep it as ad-free as long as I possibly can. Frickin' YouTube and their constant desire to make money, even though that no one's watching hardly anymore on YouTube compared to what it was a couple years ago. So thanks to the Patreons that are letting us have ad-free content. Remember, the Patreons have access to everything I do a good 48 hours before it happens. They get a bunch of behind-the-scenes content. Their equipment gets prioritized for repair first, and on and on and on. If you're interested, come help support the channel. I work on a one-to-one basis. I just make the content, and then I turn it over to you guys to see how we want to go about dealing with, if you want to help support. Thank you for the thumbs up. I appreciate all the comments. On that note, I gotta go. Gentlemen, I say thank you, and I'll see you. I am the biggest mud duck in Idaho. Bye.